Good morning. Good Tuesday morning, guys. I don't think I have any audio coming through here because probably my audio is going through the HDMI cable, which is annoying, but according to the mixer bar, it's working. Let's go ahead and send out the tweets and all the good stuff. There. And share it out there. Perfect. As a brief introduction to before we get into continuing the project, we had another response. Miguel, I just got an email from it this morning. Miguel responded to a GitHub issue. Yeah, so yesterday, Jay Hagens had basically told us that there was this thing that was possible with lifetimes, which is that we can use the colon sort of the same way that we set types and variables and variables. We can also do the same thing with lifetimes, where we said, okay, will this lifetime be really the same as A? So thanks for pointing it out. I was not aware of lifetime subtyping. I read the advanced lifetime chapter, but I thought they used a somewhat confusing example. I get the idea, but I'm a bit confused about the internals. Anyway, I played around with the example, and after using P in the printline function to see the memory location of the references, and I stumbled somewhat on an aha moment. Displayed below is his code with my comments. Okay, so we have, here's this code with and it's unchanged and it's uncommented, with the lifetimes A and B, with B subtyped to A. So let V equals world points to, and then 0x002. Result is longest of V1, V2, with V1 being high, which points to 0x001. Result points to 0x002, which makes the sense, right? This is the longest. Two variables point to the same memory location, but this is not a problem since you can have multiple non-mutable references. And then V2 goes out of scope to here. Print line. Result information at 0x002 still exists as result points to it. Hey Miguel, we're looking through your comment that you left this morning, or at least I got notified of it this morning. Looking at it this way, it makes sense. However, it also made me wonder if this is only possible in the case of strings, strs that are known at compile time. Let's say you'd like to try this on some user input or maybe some random words from a file. Would that still work? For example, I couldn't get the code below to work. Rust version 1.26. So what do you've got? V1 equals string from high. So create a new string high on the heap. V2 string from world. So two strings on the heap. Result is created up here. Longest, sending it references to V1 and V2. And that looks like the same code from longest. At the moment, I would argue that the above would never be possible because you need a mute, meaning only one reference is allowed at one time, and thus only one mutable reference at the time. This may look a bit off topic, but I'd like to confirm the idea I have on lifetimes or proven wrong, which is that we can only use the magic of lifetime subtyping in the case where we know certain outcomes ahead of time, but the compiler's having trouble seeing that. So we're just helping out the compiler, but not an actual control of the lifetimes as defined in my original post. Yeah, but this work that you're doing is pretty awesome and amazing. I'm gonna thumbs up this because that's pretty awesome. I'm also gonna thumbs up this because it was confirmed. But yeah, this is really awesome. So if anybody watches and has more answers or more to give on it, there's a lot about lifetimes that we don't know, but there's a lot more that we're beginning to understand. And this is really interesting of the memory locations where, oh well, now there's two variables pointing to the same location in memory, and that's the reason why it's okay. Okay, so with that being done, let's just continue on with the project. So we'll come over here. Oh, that's weird. CD, projects, mine, learning Rust. But we're also inside the middle of the project, so it's going to be chapter 12 and minigrep. So where are we in here? If I remember correctly, we were re-implementing sort of like what's going on here, but in our library. And this is yelling at me now. Okay, so what do we got? Mismatch types expected stir found tuple from parse input. So here is our parse. Right, because we're taking input. Oh, an input of a vector. So it's, even though it's one thing, it thinks it's two things. Oh, right. So we're not actually returning anything right now. We need to return a tuple of two things. So our idea is like, okay, we need the query and the file name. So let's do that really quickly. We know that the query and the file name is position 1 for the file, for the query, position 2 for the file name. So let's just go ahead and we're going to return input of 1, input 2. I'm waiting for the red squigglies to go away, but it's not. Mismatch types, expected reference, found tuple. Oh, so this needs to be a tuple of these. I wonder if I could do that. Let's try running it and see what happens. Cargo run. It's not run, it's test. Mismatch types, expected reference found tuple, expected type. And I found type this, according to previous error. Okay. What I really want it to do is actually expect this type of tuple back. Oh, do I need, okay, I need to give it tuple with both things. That's what I need. Right now, expected stir found tuple. It should really say, okay, well, this is also that. Not sure I'm happy with that error message here. I feel that that wasn't too helpful because I was returning a tuple and it was saying, oh, you're returning a string. So our cargo test should now pass. Okay, perfect. Now, of course, we're not done yet because there's a lot of things that could still go wrong here, and we need to verify that. So, for example, if I'm gonna say that if I'm silly enough as the user of minigrep to pass in the wrong order, well then that's just too bad. I passed in the wrong order, but it's gonna attempt to find things. So for like the tests, let's say we have we want to actually attempt to open the file, and if we can't open the file, then it's a file not found error. The other errors are if we don't add in the file, like if we don't have enough inputs. So if we only have one thing, then we're not asking for the file. Actually, it would be if we only have one thing in here. If it's a length of 1, then we don't have the query or the file. If it's a length of 2, we don't have files. So let's just go ahead and make sure that we have a length of 3 in here. So we have parse standard in. In here, we're going to have another test. Function parse input should error when not enough, when not long enough. Spec not long enough. That's a little bit, it's a little bit long, but let's try it out. Also, you're really fast, VS Code, with telling me that my code is wrong. I haven't finished it. Okay, so we're gonna open this up. We're not gonna have to return anything because we're gonna do all that inside of here. So our idea is that if we call parse input and we don't pass in a vector at all, or the vector is really this, which means that we called it, it puts the location of where we called it, but we didn't actually pass it any parameters in or any options, then we need to error it out. So we're going to say, I don't really want this to be a should panic. I really want it to pass in some errors that we can handle. So, and specifically, I want it to pass in the missing the query. Okay, so let's do, we're just gonna call it and then we're gonna match on it. So match, we're gonna call parse input. Oh, it was parse input. We're gonna pass in hello world, nothing else, and really this is a spec. Well, I guess we need this to live long enough, so we need to say that standard in. And then here we're going to pass in standard in. Okay, so we're going to match parse this parse input, and we expect to get something back. So in this case, we could get back this tuple. We're going to ignore that for right now because I expect it to get an error, and the error, I'm thinking we can create an enum of what this error is going to be, which is not enough parameters, not enough arguments. That's right. So it should probably be something like errors maybe like it would be parse error. So parse, and then error not enough arguments. Okay, so I think that's just that's catching if that's the thing. It doesn't exist yet, so that's of course the problem. And if this is indeed the case, then we want to, what do we want to do in here? I wonder if it would be better to get the return value of that. Like if I call this, I wonder if it actually will be. Let's just try that. Because I want to like assert equal, and then like the enum arms, like the enum, which of course we haven't created yet, so that makes it really interesting. I wonder if I can just say, okay, assert equal, and then in one case we're going to have parse errors. What is it called? It's going to be not enough arguments. And then on this side, it's going to be, okay, yeah, say that. We'll find out if this works or not. We're going to call in parse input, and we're going to pass in standard in. So I don't really want it to throw, I just want it to return this. I guess it should be a result, right? A result error. That's what it should be. A result error with not enough arguments as what that error is. Let's go remind ourselves what result looks like. So it's going to be rust result error. Error handling with the result type. Result type error is the result type used for returning and propagating errors. It is an enum with the variant OK, representing success and containing a value, and error, representing error and containing an error value. Functions return result whenever errors are expected and recoverable in a standard crate. Result is most prominently used for I/O. Okay, so none is error, invalid header length, and then we match here with error E. Okay, I think I know what I'm gonna do here. We're gonna do the match. We're gonna do the match. We're gonna call in parse input. We're gonna pass in standard in. We're going to look for error because it's the result that we're getting back. So an error E, and then we're gonna look for assert equal that E is equal to what is it in this case? It's gonna be not enough arguments. And then we're going to have underscore to handle everything else, and we're just going to sort of ignore this, which is, this shouldn't happen at all. And I'm wondering what, I don't think, I don't want anything like this to have. I could even put in a query file name. So we don't really want anything to happen in here. We could put in okay. And in this case, it doesn't seem to be yelling at us. This can't possibly be okay to just have empty here. I think in this case, what we want to do is just throw an error and panic. And we're gonna say we should not be okay. All right, so what's problems here? Mismatch types, expected reference, found struct standard vector vec. So we need a reference. So we're using it properly, but now it's saying, hey, expected tuple found enum standard result. So we're gonna find out here is by doing this, we're gonna run into where this doesn't work anymore because we're now making our function more, we're gonna make it a little bit more robust. And that's part of like the test-driven development here is we're understanding that before we write the real code, we'll have to refactor our test here, and we'll have to refactor this up here. But let's go ahead and get this test working, which will break this test, and then we'll just make sure that both of them work. So standard function parse input, we now know we need to return a result. So instead of returning a result of this, we're going to return result, and then do I care about what I put in here? Result of version or static. So it's going to be pretty much the same thing, which is a tuple of a reference of stir and a reference of a stir, but also the error part is this right here, which I want to say is going to be a string. Okay. The type placeholder is not allowed. Oh, okay. So I don't think I'm allowed to do that. Okay, do I have placeholder here? The type placeholder underscore is not allowed within types on item signatures. I don't have a placeholder anymore. Is it within their code? Parenthesized parameters may only be used within a trait. Only traits may use parentheses. Okay, but I want this first one to be a tuple that's being returned. Can I not do that? I don't know. Let's get the real error message and see if there's any other help with it. Parentheses parameters may only be used within a trait. So it is talking about in this result, and it's saying only traits may use parentheses. So it's not happy about this right here, which is a tuple of two stirs. Result empty parentheses with the angular brackets, right? Is that how we do it? Oh, you're right. Result with angular brackets. You were very right. I forgot that. So this is going to be like that. And that. That makes more sense. And now it's fine. So let's go ahead and run these tests. Thank you, Miguel. Okay, so expected enum standard result found tuple. So here the first error is yelling at us now. So this is now messing up. But instead of changing this, we need to change the test to work properly. So now we're no longer going to be getting just the what is it called? Tuple. We're getting a result. So we need to unwrap it. So let's enter it in, let vec this. So let's then do a dot unwrap. That caused an error. Mismatch types, expected enum, standard result, found tuple. So perfect. Now we're going to respond with, well, so we need to make a choice, right? Because we need okay and error. So let's go ahead. To return a result, you need to return either OKT or error. Yes. And good morning, Danny. Welcome to the stream. So we need to do a quick test here. So if input.length is less than 3, so do I want to handle the error first or not? I kind of like the idea of just saying, hey, if input of length is equal to 3, then we're fine. Then we're going to say, okay, we want to return a result, which is going to be the okay. And I can never remember, it's this equal bracket. It's this angle brackets, right? Or like this. Double check here. It's parentheses. And then we're going to respond with the tuple, which is input of 1, input 2. Now, else, we're going to respond with an error, which is going to be the string in this case. And this is going to be a new string, so it's going to be string from, and what we're looking for, it's not enough arguments. All right, so no errors showing up here. Let's run the tests. Expected 1 field, found 2. So we need an okay here. Expected 1 field, found 2. Oh, I guess it's this tuple. So I wonder if I could just do that. All right, so now our tests are passing. So we now are saying, okay, if we don't pass in enough arguments, then this is going to run. And we can change this by saying like a bang here and make sure that our tests really, really are getting the error part. Yep, and it's failed. Tests parse input should error when vector is not long enough. That's failed. Thread, addict assertion, left does not equal right. So perfect. So our test for that error is working properly, and we're making this parse input a little bit stronger. So if we don't hand it enough arguments, or if we hand it too many, it's going to error, which is not enough arguments. And in reality, we could hand it 4 arguments, and that's also incorrect. We could just say not the right amount of arguments. So, not the right amount of arguments expected to got, and so we're going to then ignore everything else, and then this is where that assert that we learned in that last chapter, that it's just going to do a partial test for us. So just like we're going to do the red-green refactor, which is we're going to run the test, make sure that we're getting it failing here. Then we're going to come back in and fix this. So we're going to say string from. I want to format this. Does format return a string or a string? I'm curious now. Maybe we can find out in here. Format. Oh, a full string. So perfect. So I don't even need the string from if I'm going to use format. So we're going to say format. And it's going to be the exact same thing here. Not the right amount of arguments, expected to, got. And what we really want to do is pass in, is like figure out what we got here. So it's going to be input length -1, because I'm not counting this first one here, which is that the path of the entire, of minigrep itself. So if we save this, then we should still, everything should be fine now. Okay, so did not error out. Left got 0. Right, because we didn't pass it, we passed it to 1. Not the right amount of arguments, expected to, got. Oh, I thought that it would, it is exactly the same except for this last part. I thought that it was going to be nice with that. Let's go double check the book here. Rust, testing, sort of like fuzzy. Assert equal substring. Asserts that two expressions are equal to each other using partial equal. On panic, this macro will print the values of the expressions. I was hoping that I would be able to like return the full error message, but have it be a dynamic one. I do remember that the book went over this. Let's go take a look at the book too. This is Rust book. The wrong one. Test organization. Is this 11.3 test organization? Okay. Not sure if we need anything else with this. Testing private functions, integration tests. Submodules. Okay, we got all that. Integration tests for binary crates. Let's go back and see if we can find where they're talking about the substrings. Okay, I think it's the first one, maybe. So the assert equal. Okay, we have the assert. Test inequality of the assert equal, not equal. Okay, adding custom failure messages. I think this is where we're getting closer here. And add a custom message to be printed with a failure message. But we don't want it as part of the test. We want it as actually the error that's coming back. Oh, is it part of the should panic? Because I don't want it to panic. Okay, so here's the failure message indicate that this test did indeed panic as expected, but the panic message does not include the expected string. Oh wait, wasn't there? There was a yeah. So this should panic here expected equals, and this. Okay. So I think in this case, what I'm gonna have to do is just sort of know that this is gonna be got 0 in this case. And we're just gonna have to accept that that running the randomized test is gonna be not quite as easy. But that works, so we know, like, okay, if we pass in absolutely nothing, that doesn't work. So one of the theories of testing is like, okay, we got the happy path, which is this one right here. Although it's not fully happy yet, because this is just making sure that we passed in, that we're getting our query and the file name back. What would also be good is to make sure that the file name exists there. So we kind of need to test that as well. We also are testing here when the vector is not long enough, or when it's too long. So when vector not, so input should error when not enough, when not right, not correct number of arguments. Okay, so there's this test, and then another one is what if we did it wrong when we flip them around, if it can't find the file. So we need to be able to find the file also. So there should be like an exists here, and we can test that, or we can just attempt to open it. And if it doesn't open, then that's an error. So this is another one here. So function parse input should error and file not found. Okay, so we'll do the same exact thing, that's standard in. Vec, and the first one doesn't really matter, it's hello world. This poor little function's starting to get a little heavy, don't you think? Yeah, well, I also enjoy doing this like test-driven development. It is getting a little bit heavy. It's getting more real world-ish. And I know I'm sort of like deviating from the book in this case, but I also want to practice doing like actual test-driven development in Rust. Sort of like get the cadence of that. Get what it feels like. So in this case, like we have this parse input here, and if we want to attempt to open the file, which we have right here, home.txt. So if we don't hand it the right thing, we should get that error out. So it's hello world. It's our search string, which is, we could just say hello, or maybe I'll just call it the query. And then finally, we can just do h dot does not exist .txt. So we should match this. So match parse input. We're going to pass it a reference, just the standard in vector that we just created. And then we're going to check for the error. The error E. This should assert equal that E is the same as not the right amount of arguments. In this case, file not found. And of course, what are you yelling about? Okay. Then we have our okay, and we don't care about this input, and we just want to panic. And we're just going to say file should not be found was. So we'll save this. We should run it, and the test should fail. When file not found, okay, so file should not be found, it was. And I think that's mainly because this parse input actually isn't doing anything. Although this is parse input, isn't it? So that its job isn't to do this. So now that I actually think about it, it is that you're correct. This shouldn't be really doing that. Kind of, yeah. I was thinking about this function doing too much. Because all its job really is parsing this input. You're right. I don't really need this. I think this is good enough for now. So now if we come back to main, we can use it. So user stand.io read. Do I even need this in here? We want to include the extern crate minigrep. Which will allow us, okay, so we collect the args from the standard input, let query equals args. Well, we're sort of doing that here. What we really want to do is then call in so it's going to be minigrep and use minigrep parse input. Parse input here. So we should now be able to do let query file name, set this equal to parse input, and we're going to pass in args. And then we need to unwrap it. Unwrap. Suppose you make sure you're on wrap here. Mismatch types, expected reference. We need to pass in a reference to it. Expected reference to stir, found struct a string. So it's a full string that we're passing in here. And I guess that's because that's what we're getting here. So because it's a full string, we need to play with our library a little bit more. Instead of these, they need to be full strings, don't they? So toString, really do this all at once. To now, of course, when it's found struct expected reference to stir, found struct center string string. Do we care about giving ownership to parse input? Input is a vector of a string. Shouldn't doing vex string do the same thing? Well, like right here, just say string. This is, well, it's still a reference to it here. Expected stir found struct string string. Even though I'm giving it a reference to it. Oh, okay. Expected type standard reference to standard vec reference to stir. So I think instead of reference, it's string, which means this doesn't need a lifetime in here. Okay, let's see if this works. Cargo test. Oh, it did not like that at all. Okay, input 1 expected reference to stir found struct string. For this is our okay input here. Consider borrowing here for input 1, 2. Right, because if we're passing now, it is a vector 2 string, so it's a full string in here. We're passing and giving ownership into well, it's ownership into this vector. So I don't necessarily want to give. It's a reference to the vector in here. Let's borrow. And mismatch types, expected tuple, found references. Oh, I put this in the wrong location. Okay, let's try it again. Okay, everything is running there, so let's now head back to our code to main rs. So now what are you yelling about? Expected stir found struct standard string string. I think I just fixed that, didn't I? Let's try running it and see what we get there. Cargo run. Well, it worked. Thread main panicked at called result unwrap on error. Value not the right amount of arguments. Expected 2 got 0. Perfect. So that's exactly what we wanted to do. So cargo run, and then we want to say something like hello and hello.txt. No such file or directory. That's actually from down here. So if we look, it is poem.txt. So not hello.txt. And then it works just fine. So all of that to basically replace 2 lines with 1 line here, but it's a tested line. I don't know why VS Code is not updating and giving me this, because it's incorrect. It should update. These are not meant to be. I don't like it when things like that happen. Okay, so let mute file equals open, error opening the file. File content, string new. Also, I kind of want to put use extra and create up here, and then make sure that we have our uses separate. This doesn't need to be there because we have our prelude. So our next thing would be to add in to our library the ability to open the file and get the content. Although for right now, we should go back to the book and actually see what we were supposed to do. So where was that? Writing tests. We were on IO project. We have this. Let's go to the next one. Okay, so we're factoring for separation of concerns. So extracting the argument parser. We'll extract the functionality for parsing arguments into a function that main will call to prepare for moving a command line parsing logic. The source library s listing 12.5 shows the new start of main that calls the new function parseConfig, which will define in source main rs for the moment. So right, we just went straight to the library and they did not. They went to parseConfig out here, takes in args and a, okay. We're still collecting command line arguments into a vector, but instead of assigning the argument value at index 1 to the variable query and the argument value at index 2 to the variable file name within the main function, we pass the whole vector to parseConfig function. The parseConfig function then holds the logic that determines which argument goes in which variable and passes the values back to main. We still create the query and file name variables in main, but main no longer has the responsibility of determining how the command line arguments and variables correspond. This rework may seem like overkill for a small program, but we're factoring in small incremental steps. After making this change, run the program again to verify that the argument parsing still works. It's good to check your progress often to help identify the cause of problems when they occur. So yes, of course, this is overkill for this small project, but it's more of like we're using small programs as a way to sort of like get the habits correct, if that makes sense. So how much time? It's 7:50. A lot to go through for this one. Let's see what the next, let's go at least through to here. Grouping configuration values. We can take another small step to improve the parseConfig function further. At the moment, we're returning a tuple, but then we immediately break that tuple into individual parts again. This is a sign that perhaps we don't have the right abstraction yet. Another indicator that shows there's room for improvement is the config part of parseConfig, which implies that the two values we return are related and are both part of one configuration value. We're not currently conveying this meaning in the structure of the data other than by grouping the two values into a tuple. We could put the two values into one struct and give each one of the struct fields a meaningful name. Doing so will make it easier for future maintainers of this code to understand how the different values relate to each other and what their purpose is. Note, some people call this anti-pattern of using primitive values when a complex type would be more appropriate, primitive of obsession. Listing 12.6 shows the addition of a struct named config defined to have fields named query and file name. We've also changed the parseConfig function to return an instance of the config struct and updated main to use the struct fields rather than having separate variables. Okay, so this is really going to be let config equals parseConfig. So I think the big thing is, if we're going to have the library return this struct, then we're going to need to put the struct into the library. So for example, in here, we're gonna want to change our tests to say, okay, we no longer want to return just a tuple here. So int here we have we create our standard in, we then run this query here, but we don't want it to be just let query file name anymore. we want this to be just the response, right? This is going to be they're calling it like the config, so we can call it that. So let config equals parse input, unwrap it to get the result of it, which is the config structure. And then we want to assert equal query is going to be config.query. I was talking about changing vec to vec string so you can get rid of them annoying two-string your standard in. Oh, vec vec string for here. So like this, where it's is that right here where it's vec string, and then we shouldn't need these. Will this auto cast them? Also, I think you need to be a capital V, right? Or it's not yelling at me, so maybe it's fine. Let config equals parse config, unwrap, and then we're gonna now assert that config.query is our query, and config.filename is this. Okay, now it's updating. Mismatch types. Expected Boolean found array of 3 elements. Okay. Oh, is it gonna be something like this where I need this is gonna be a vec of string equals to vec new. Mismatch types, expected struct centered. Okay. Vec new. This text function takes 0 parameters, but 1 parameter was supplied. Okay, so that wasn't good. That's not how to do it. Would it be just? Well, that doesn't error out, or maybe it's just still figuring that out. We should have an error now, however, that config doesn't exist. Because we haven't created the structure, which is going to be in the library for parse config. So I'm thinking this one we're going to have to change from parse to just maybe like the library for like minigrep. So like the grep library. And maybe it could be input and then parse. So if we do, what if we do change this to mod parse, this will be a function input. Then of course these need to change. So super parse, that's fine. These are all now just, instead of parse input, it's now just input. And in main RS, it's going to be same thing here. Bringing in, create minigrep. This is going to be, I want parse, so we can have parse. Cannot find function input in module parse, but it's right here. I don't know why sometimes, like VS Code seems like it's going a little bit crazy sometimes. Cannot find function input in module parse, not found in parse. Input. Unless input is like a reserved keyword, then it would be bad. Should we use minigrep parse, bring everything into scope. But I wanted to say like minigrep like parse, so parse : input. That way I don't have to like bring everything in, I can just find it in there. I guess like that's what I'm curious about, is like why. Yeah, I don't. Did this not come in normally? Do I have to? Allow. Parse maybe? Wait, what? Oh, you're talking about why it flagged. Yeah. I don't know about that. But it's 8 o'clock, so the next thing we're gonna do is we set this up. We need to remember to run our test again, because everything is gonna break. Because the current thing that we're gonna be doing next is, and let's come down to our README to update that. Sort of like currently at, and for this project, we're going to be updating the parse function to return a struct and not a tuple. Ha! Yeah, I could see I can see Twitch being like weird with that with chat. It's stuck on insert mode. What did I do? Actually, I think I froze my terminal. I can move it around, I just can't. Oh, I can't even sleep it anymore. Okay, well that's a bit disconcerting. Yeah, close the terminal, we're gonna lose that. Reopen it again. Vim is normally pretty good with that. Talking this project's mine. Learning Rust. So our swap is still here. If we cat the .readme swap, well, let's just do vim the readme. Let's recover. Covered completed. Let's go ahead and take a look. Okay, so updated the parse function, return a struct and not a tuple. I think. And then we're gonna say, okay, need to run and fix tests. Save this. We can now remove that readme swap file, and we can come into here and add in everything, which is created parse function, but now starting to refactor to structs. Work in progress. And we'll send that on up. So I have the code for everything up on GitHub. I have links to the code with GitHub on the stream description here, but also in the YouTube videos, their description as well. I am doing these streams or learning Rust and going through the book every single weekday morning at 7 a.m. Mountain Time. If you're seeing these videos and you'd love to stop in live, we'd love to have you. I have a link to my Twitch account in the VOD description on YouTube, or you can just follow me on Twitter. Unnamed Outsider, thanks for stopping by. It's at the end though. So hopefully maybe you could stop by when I'm not about to end, and then we're gonna see more things being added. You'll notice that at the beginning here, it's a little bit slower, but that's actually how test-driven development works. It slows the project down at the beginning and then speeds it up near the end, and specifically afterwards if we were to use this for real, or if we wanted to make any changes to it. Anyways, with that, I'm gonna take off and sort of go get ready for my day. I hope that you all have a great rest of your days. Thanks for stopping by, and see you next time.